This is a quick review of solubility and conductivity. In class, we had 3 different substances. I had copper chloride as a solid. I had deionized water, which I don't have labeled here, but I had deionized water in its liquid form. And I had copper chloride as an aqueous solution. An aqueous solution, a solution, means that the compound is mixed with water. So if something is a solution, water is in the particle diagram. It is mixed with water. And in this case, these were our predictions. So these aren't exactly correct. We're going to correct them in a second. And we initially said that with our copper chloride, we were going to have 2 chlorines, so 2 anions, with my copper, with my positive, because I had CuCl2. It was also a solid, so that means that these are going to be very close together. Very little space between, so very dense. My water was going to be just water, and it's deionized, so that means that there's no ions in the water. All of the ions have been removed, and there's this space here because it's a liquid. Well, then we said that when we put the copper chloride into the water, it was going to make a mixture of 2 compounds. However, then what I did is I put some electricity through it to see if it would light up a light. In the case of solid copper chloride, it did not light up. In the case of pure water, deionized water, it also did not light up. But for some reason, when I put the copper chloride in the water, it did conduct electricity. And so that tells me that it can't just be the 2 compounds mixed together, because one compound didn't light, the other compound didn't light, so just putting the 2 compounds together would not cause it to light. And so we went into how a nonmetal gains. And then we said we were actually going to change this to attracts. So our nonmetals attract electrons, and it forms a negative ion because I have more electrons than protons. My metal, we're going to change this to breaks attraction, to its electron. And so, because it's breaking the attraction to its electron, it forms a positive ion. There's more protons than electrons. And we said that conduction allows for the flow of electrons. It allows our electrons to flow. And so, when we look at this, this tells us that our compounds together, when mixed together, they broke apart into their ions, and we knew this because in the observations we made, we saw that my negatively charged side of the wire connected to my battery, so I followed that, it lit the light, and that negative side had a lot of brown particles that had some shiny flecks in it that lined my paper clip. And so we realized that that was the copper. So copper was lining the negative, telling us that it had a positive charge because opposites attract. We also noticed that it smelled kind of like a swimming pool. And so that swimming pool smell is chlorine. And so chlorine is a gas at room temperature. So it makes sense that we smelled the chlorine gas, and it makes sense that copper was a solid at room temperature once we split them up. So what this tells me is that my compound broke into its ions, and that's what soluble means. Soluble means that its ability to break into ions in water. So it breaks into ions in water. In order for there to be conductivity, in order for there to be a flow of electrons, the flow of electrons must occur between ions. Ions must be present for conductivity to occur, for something to be conductive. And so we can see that because what happens is my electron is negatively charged, and so it's attracted to this positively charged copper. But copper is positively charged because it it broke that attraction to its electrons. It now has a complete valence shell, and since it has a complete valence shell, it is unreactive. It is not going to accept any electrons. So that electron isn't accepted here, so it moves on to the next one. The negative charge is attracted to the positive charge, but again, the copper has a full valence electron and does not accept it. So the electron continues to be passed on in this way. And that's what allows for the flow of electrons. It gets passed between the different positives until it reaches the positive electrode and then goes around completing the circuit and does the whole thing over again. So again, if something is soluble, when we talk about the solubility, it's the ability to break into its ions in water. Conductivity, if something conducts, it allows for the flow of electrons between ions. If you do not have ions present, there will be no conductivity. There will be no flow of electrons. There's no ions for them to flow between. Something else that I'm going to mention here is that in order for something to be soluble, some compounds are soluble while others aren't. And so the reason for that is because of the attraction between the atoms. And so if I have a high attraction, it's going to be less soluble. High attraction means it's less likely to break into its ions. And so the way that we can tell about the attraction is, if you remember from the last unit, you can look at distance, you can look at shielding electrons, and you can look at charge difference. This is new in this unit. And charge difference is exactly what it sounds like. It's the difference between the charges in our ions. And so here, when I look at my copper chloride, I have Cu, Cl2. And so that tells me that chlorine, so I need to figure out the charge, the number of atoms in my formula or in my unit cell, and my total charge. So here I have chlorine, and when I look at the periodic table, chlorine has 7 valence, so it's going to form a -1 charge. It's going to form an attraction with 1 electron to have a complete shell. In my formula, I have 2 atoms of chlorine. When bonds form, they form to make a neutral compound. A neutral compound is more stable. And so that means that my overall charge, I have 2 atoms, both with a -1 charge, means my total negative charge will be -2. My copper, I don't know what the charge on my copper is. It's a transition metal, so it doesn't follow the rules. However, I do know from looking at my formula that I need 1 atom of copper in this formula. I also know that my compound forms because it will form a neutral compound. So to be neutral, I need to cancel out the -2 from the chlorine. So that means I need to have a +2. Well, +2 times 1, or the +2, the charge, what charge times 1, the 1 atom I have, will give me a charge of +2. And in this case, it's going to be a +2. So my charge difference between copper and chlorine, it doesn't matter that I have 2 chlorines, it's the charge difference between my ions. My charge difference is 3, because on a number line, there is a difference or a spacing of 3. So this isn't 2 minus 1. That's not correct. It's how much difference there is between the charges on a number line. So this would have a charge difference of 3. Compare this to something like aluminum sulfate. Aluminum has a +3 charge. Sulfate has a -2 charge. And so my charge difference is a 5. And so if I told you that one of these is soluble in water and the other is not, or if I asked you to rank them in order of solubility, aluminum sulfate would be less soluble, would be less likely to break into its ions because it has a higher attraction due to its high charge difference.